So hello everyone. I'm happy to host the third talk of our Urban Issues Lunchtime lectures from the Institute of Urban Design of the Leibniz University of Hanover. Today we have Mateo Neira with us. He's an urban designer at Foster and Partner in London and a PhD candidate at the Alan Turing Institute. And he will be talking about seeing cities through data and models and his ideas on data-aided design. Mateo, the floor is yours. Thanks a lot.
Oh, great. Thanks a lot, Ben, for inviting me and for that introduction. So just before I get into the presentation, I thought I'd share a little bit more about myself. So I actually studied architecture. I graduated around 6 years ago. And right after I finished architecture school, I started working in practice and was mostly involved in medium-sized developments and kind of working at the urban scale. And that got me interested in how to derive insights that would impact design and how to evaluate different design strategies into making right decisions and creating the right types of environments for people. And because of this, I went on to do a master's at the Center of Advanced Spatial Analysis at UCL here in London. It was a master's on smart cities and urban analytics, and kind of dove deep into how to use data and different methods to kind of really gain insight about how people use cities and how cities function. From there, I joined Foster and Partners in the urban design group as an urban designer and big data analyst. And at Foster and Partners, within the urban design group, is a very multidisciplinary team. So it's composed of anthropologists, urban planners, urban designers, traffic engineers, and economists. And our role within the office is to develop urban visions for different areas around the world where we have work, mostly working in large scale master plans, so areas around 5 square kilometers or larger, and analyzing those contexts through different lenses. And my role within the team has been in gathering up as much data as I can in the different contexts we're working and derive insight that would then be translated into different design strategies for these master plans. And around 3 years ago, I also started a PhD, which is within the Center of Advanced Spatial Analysis, as well as the Alan Turing Institute here in London. I've been working with Elisa Arcaute and Stephen Marshall as my supervisors, and I've been mostly focused on these data-driven models to understand segregation between inside cities and the impact of transit infrastructure on segregation and how people use and interact within cities. And these are the sort of projects we've been working on within the office. Like I said, very large master plans and really developing an urban vision for different areas that are developing quite rapidly, and governments looking to provide solutions at the urban scale to this rapid urban growth and population growth. So a lot of projects in China and Middle East mostly, but some smaller scale projects as well within Europe and the US. And the things that I'll be talking about today is first just giving a brief introduction to what urban modeling and data analytics is, and how we use that for design purposes and master planning, and then go a little bit more into detail about specific projects I've worked on, going from use of forecasting land use distribution in areas where there's no context we can go by. So literally working with a blank slate and how we look at other cities to kind of inform the design decisions we make. Quantifying urban form to understand the different contexts we're working in, and inform, again, those design decisions. Then talking a little bit about new data sources such as images, Google Street View, and how this could be used for urban analysis as well. And trying to tie this all together and talk about how from all these information we're able to gather and the insights that we derive from these analysis, how then that gets translated into specific designs and master plans. So before I get into it, I just want to make a definition of what I mean by models or what models means in these contexts. And I mean, models just generally is some sort of representation of anything we're interested in. I mean, in architecture, we usually, when we talk about models, we're focused on this iconic sense of models. So 3D models that represent the physical reality we're working in, or that we're trying to build and materialize. And then there's other type of models, and the one I'm going to be focused on here is symbolic type modeling. So this is more of the type of models you would see in physics and math, where we try to boil down the reality we see into very simple rules to understand how they interact, and how those rules then can give the richness of varieties we see in the world. And these models, they're useful to ask kind of what if questions. So to test different assumptions we may have, and try to forecast kind of different design or planning decisions we have into the future. And urban modeling, in this sense, has been around, I would say, for around 60 years. And just a little bit of historical context on this, it goes back, and it has kind of roots within physics, and kind of the evolution of physics through history. So going from Newtonian dynamics, really thinking about simple systems where we know how two things interact. To be more precise, for example, gravity, where we know how mass and different bodies interact to attract each other. And then later on, concepts such as the disorganized complexity popping up again in physics, to understand, for example, the movement of gas particles and how that leads to different properties at the global scale. And more recently, and this is more related to what we see in urban modeling and urban science in general, is the concept of organized complexity that is kind of in between simplicity and disorganized complexity. So systems that are not completely deterministic or simple in the sense of elements just interacting together and being and the system being the sum of its parts, but not completely disorganized either, but having some structure that gives rise to emergent phenomena. And this kind of seeped in through urban theory in the early 60s. And we see a lot of this in the work of, for example, Jane Jacobs in her great book of Great American Cities, and talking about this complexity within the urban environment, and how you really need to tie in different uses and consider different aspects of the urban environment working together to give rise to places that create livable environments for people. And there's a lot of history within that as well, of them trying to materialize these ideas, or being able to quantify these ideas in a way that we can actually measure and understand these things. So initially, a lot of it was related to understanding population growth, as well as land use models, so how land uses are distributed within cities. And now to a lot of new ideas that have popped up, for example, in space syntax with Bill Hillier and the social logic of space, looking at that interaction of the street network, or how spaces are connected to each other, and how that kind of dictates how people move and the interaction between these two things, as well as other newer models, again, to explain land use distribution, where people decide to put their businesses and so forth. And taking this together with kind of recent advances in both computational capacity and availability of data in the last 10 years, there's been an infusion of data science as well. So bringing together kind of computer science, maths, and how we usually approach this in a general sense is dividing the city, or thinking the city as having different layers. And we can look at these layers through different perspectives. So just to simplify, it could be the infrastructure that makes the city work, the natural environment, such as green spaces, parks, suburban areas, the different functions, so where residential areas are located, where commercial areas are located and how they interact together, the transport networks that kind of bind these areas together, and then of course the people that actually live in these places and interact in the day-to-day setting, and then the buildings that host all these activities. And we can take these different layers and try to model them in a host of different ways to understand how they interact and feed back into each other, and give rise to different places like New York and London, or other cities like Hong Kong, Beijing, and create livable spaces for people. And when looking at cities through this lens, one really important thing to consider is that scale matters. So really, depending on what your focus is, you would look at these different scales, both in terms of time and in terms of space. So depending on what you want to focus on, for example, if you're focused on how people interact with space, you may be working at the building or neighborhood level. But when you want to understand land use interactions and infrastructure, you'll be looking at a much wider kind of city scale region. You could also start thinking about how different cities interact with each other, and get to other topics such as migration flows, et cetera, at the regional level, and national level as well, when thinking more about the economics of these places. And then the temporal scale, again, going from everyday interactions happening maybe at the minute, hourly scale, when you're looking at very specific urban areas like plazas or parks, and then going all the way to social interactions that develop over days, weeks, or months, and how different groups start to form. And for example, in urban segregation, this is the scale that we usually work in, and all the way to economic networks. So then how people then kind of agglomerate to form different entities, corporations, businesses, and how these interact at this kind of bigger level. So with that in mind, and that as a background, I'm gonna go a little bit deeper into very specific projects that we've done, looking at different scales, and as well as looking at cities from different perspectives. And then at the end, I'll try to bring this all together, about how we bring this to the actual design practice. So the first thing I'm going to show is work I've been doing in trying to forecast land use distribution. And this is particularly useful when working in areas where there's very little context. So for example, we had a project in Kuwait, literally a city in the desert, and not much else, not much going on around. So the question was, in a place that's going to be completely new and that has no cultural immediate context. I mean, you have the cultural context of the country, but nothing that has been built there already. How do you think about distributing different land uses and thinking about city planning? And one thing we've been working on is looking at how the street network influences the decisions of where people locate in terms of their residential and commercial activities. And this is usually driven by the movement of that is created by these infrastructure networks. So if we think about the morphology of the city, and for example, here we have a base map of plots, lots, and the street network, and we start to kind of abstract different elements away to just have the street surfaces, and then we present these as just lines that are interconnected to each other. We could start using different methods to understand how this connectivity pattern influences on people flow, and how that people flow influences then on location strategies, so where people locate to put their residence as well as commercial activities and so forth. And we've done studies then applying these models to existing places. For example, here we have a map of the Islington here in London and the road network. And the colors here highlight which roads are highly connected within that network. And this is where you would expect most people to travel in as they go through their daily activities. So places where you see more red is where you would expect to see more pedestrian and vehicular flow, and therefore usually is where you would find also most commercial activities. And then as you go through to the outer edges or to these inner places that are in orange, a lot less movement, a lot less activity, and again, where you would expect people to have a lot more residential. So we tested this hypothesis by trying to actually forecast that land use using only this road network connectivity as a guide, and then comparing that to the actual land use distribution that the city has. And in this graph here at the bottom, we find that we actually get a good match, or we're able to predict that land use distribution with some level of accuracy. And what we did then is to apply this in the same context for a new area. So if we have a place where we know what the road network is going to look like, we have planned the city in such a way, and we need to figure out for planning purposes where different uses in that development is going to be. We could start applying the same principles of calculating those connectivity measures on the street network level, and then using that to define block accessibility values that then will drive detailed land use plans for that area. A completely different thing, but again related into quantifying different aspects of the urban environment, is to understand the actual morphology of these places. As I mentioned, the street network kind of defines these blocks that then are going to host all the different uses that we have in the city. And when actually working in not now in places that don't have anything already built, but new developments or redevelopments within existing environments in cities, how can we quantify the urban form in those places? So when we design, we can be closer to matching that context in terms of the building environment, and also to be able to compare different cities and understand how they relate in terms of their historical development. And one way we have found of doing this is, for example, of looking at all the blocks in a city. Here we have, again, just a cutout of an area in London. Here in this white section in the upper right-hand corner is the Thames. Here in these blank spot, these are pegs in the city, and then the rest is all the different urban blocks colored by their size. And we can start classifying these blocks and understanding these different areas of the city just by looking at the size of these blocks as well as their form factor, which essentially is how regular or irregular these blocks are in any given area, which you can see in this graph here, where we have plotted. So as you go up in the y-axis, you have blocks that are a lot bigger in area, hosting mostly a commercial or utility uses such as transport stops, metro stations, and so forth. And as you go down, smaller blocks hosting more residential uses. And on the x-axis, you have this form factor, which is how regular, irregular those blocks are. And we can then start abstracting that away from how they're connected in the city to seeing them laid out more in a grid-like sense, where similar blocks start to cluster together based on these different forms. And we can start again to look at how the form of the block is tied to the different uses it hosts, how different cities exhibit different morphologies in terms of the types of blocks you would find. So places like LA, you would find that they're mostly made up of big, huge blocks with residential towers, whereas places like London or Barcelona, Madrid, or so forth, you would find much smaller blocks with finer details that are more related to its historical development. We could also start not only to think about the city in this 2D sense of looking at the plan view, but then also integrating 3D information to understand what's happening at the actual scale people use the city. So looking at the streetscape and then trying to understand people experience, how they might experience the environment in these different areas. So again, using building footprint data that is now available through most municipal websites, as well as the road network, we can start creating these street sections in large urban areas to understand how they're distributed, and then also how different cities are similar or different in this respect of the urban streetscape. So we applied this to 6 different cities, again, very different contexts, some in Europe, some in the US, London, New York, Madrid, Washington, D.C., San Francisco, and Barcelona, cities with different sizes and historical developments as well. And what we see here is a map showing that streetscape map in terms of the street widths and building heights for these different areas. So places, for example, the center of London, have a lot of high buildings, creating the streetscape with very narrow streets. But places like, for example, San Francisco, especially towards the suburban areas, like really wide streets because of the high vehicular use and smaller housing that are defining this streetscape. And when we again abstract it away and just look at those measures, we can start to see how different cities cluster. In this graph in the bottom right hand corner, you can think of it as kind of the footprint, a general footprint of a fingerprint of these different cities in terms of these streetscape. And you see how, for example, Barcelona and Madrid have a very similar profile, mostly have smaller streets with medium-sized buildings that is exemplified by this curve. And then other cities like London, as well as San Francisco and Washington, D.C., again, showing very similar patterns. And then New York being kind of an outlier by itself, exhibiting a very different kind of a streetscape or that you can translate into urban experience from these other cities. And from this, we can actually start making more more defined questions like what are people experiences when walking down or using these environments in terms of the amount of information, visual information you receive, in terms of how these streetscapes change as you walk through different areas of the city. So we developed a measure by using something called Entropy that measures the amount of information that's contained as you traverse these environments. And again, we can apply that to these entire urban areas. And what we start getting this picture that you can relate to the intensity of use or urbanity in these different cities. For example, London, just by looking at this measure of visual information, you already get a glimpse of where the city center is, and again where the suburbs kind of spread out through the outer layer. Same thing with San Francisco. The yellow area highlighting places with this high visual information, again, relates to places of a lot, like where you find vibrant environments. And this has served a lot. And also then when thinking about our master planning or design approaches and new developments, about how to create the right diversity in terms of the different buildings that are located in different areas, how we lay down the street networks and so forth to try to recreate these vibrant environments. And the last thing I wanted to show in terms of more detailed analysis is how, because of the new data sources that has started to come up in the last 10 years, we could actually start taking advantage of this and extracting information from these images that can derive useful insights for urban planning. And this has been done a lot in the recent years. There's a lot of research and, for example, trying to identify different types of activities through looking at urban imagery and being, again, able to compare how different cities are or how similar they are in terms of the type of uses that people give to the space and so forth. One of the things we've been using this for is to understand how green different areas of the cities are. So here we have an example of Phoenix, where we took the road network and we queried Google Street View imagery using a 360 of all the points in the street network. And from each image, trying to extract how much green is visible to give a green index. So we actually derived this from a research that was done at MIT at around 2014 and applied it for our own purposes. And again, what we're able to derive from this is a map of Phoenix where we see the roads visualized based on the amount of green that you're able to see where you're traveling those streets, as well as a general green view index of the whole city. We're here for this area came out to around 12.72%. And the way we're, again, using this in terms of supplying insights for urban planning and design is that in a project that we had here where we had to do some urban architecture and think about which places might be suitable for greening strategies, we can kind of get a quick overview of which places need it the most and which streets might benefit from for planting more green or creating kind of green corridors to increase the vegetation and create more pleasant environments. And a second thing we have also been working on is to abstract information that would let us a forecast or information about cities that we usually wouldn't have access to just from the images. So using both street networks, but also Google Street View. So here we looked at 100,000 different cities around the world, again, queried Google Street View, as well as getting the street networks for all these different areas, and try to extract the information from these that we can use in other tasks, such as looking at which places are more urbanized or cluster different cities to understand their historical developments and so forth. And that was divided into 3 stages, which was mapping the information we're obtaining from these data sets, exploring what the model is capturing by modifying different parameters, and then using simple regressions to be able to predict different values, such as land use, or in our case, just how urbanized different areas of the cities are. And here's a result from that, where we trained a model on our urban street view images. And we were able to get an accurate picture. In this case, we were testing it in London, about which areas are more urban and which areas are more green. Again, in this map, it's something we would expect and we would already know. And for London, we have a lot of information on, but we think of other contexts where information is scarce, like again, such as Middle East, China, or other places where we don't have information available, but we do have these data sets of images. We could start creating this information that we can use to analyze the different contexts better. And just to end this and try to tie this all together, is all the things I've shared before is methods and tools that I use kind of in my day-to-day work to try to extract information and knowledge from data and gain insights into these different urban contexts and how cities function. But within the practice, what's really important is then how we can translate this into actual design strategies that will be implemented in the different projects we work on. And what we have been doing is collaborating with architects when we work on these projects, providing insights for them that they can later translate into this design strategies, but then also creating different typologies of blocks that we can use within our master plans. So taking all these information, we've developed this matrix where we have different use types, different density types, as well as different geographies where we might work. And by taking into consideration all this information that we're gathering and gaining insights on, we can start creating block typologies that we can use in different projects that take into consideration different climate conditions, different cultural contexts, as well as the specific urban morphologies and the built environment of the places in which these projects are embedded. So then we end up with these sort of interactions between these three axes we're working in, that lets us quickly kind of test different design strategies at the larger scale, and see what works, what doesn't work, and quickly iterate and feedback until we actually arrive at a final design that really encapsulates the urban vision we have for different areas. and part of this is trying to optimize this process, again, so it could speed up the iteration process of the design, so we don't spend so much time on doing the manual labor of trying to create the 3Ds that we then use to visualize and see and evaluate how they're working, but actually then just focus on making the right decisions at the bigger scale. So we can iterate through different block typologies really quickly. We have scripts that kind of modify individual buildings to comply to different brief requirements, such as the gross floor area that's required, the floor area ratios, and then run these through various analysis, such to evaluate how it's performing in terms of wind and heating, and then also how it fits into the wider context of the places we're working in. So if it has a good relationship with the existing urban morphology, if the distribution of land uses makes sense in terms of what we would expect to see in existing urban environments and so forth, and end up then creating also a detailed geometry that then we can use to create renders to exemplify the final urban vision we arrive at after going through this iterative design process. And again, we're collaborating with visualization artists to then be able to actually create renders and videos that lets us see what these places might actually look and feel like. And just to give an example of this, this is a project we worked on near in a coastal city in China. It was a redevelopment of a 8.5 square kilometer area. So it was around 700 individual blocks that would host around 17,000 individual buildings. So again, it was important to one, be able to use the insights that we were able to gather from analyzing the context around the area, and also the knowledge we have built in trying to understand how existing cities function and what makes good urban environments. Being able to control what's happening at the very local level, at the blocks, and how buildings relate to each other, but then also go back to the bigger scale and be able to see how, for example, the skyline would look like, control individual areas, height requirements, and so forth, to be able to meet the brief requirements, as well as, again, creating environment that be promote a healthy and healthy living environment and quality of life for the people that would end up using these spaces. So going through this process, we were able to, again, define how the final skyline would look like at the bigger scale, while having control of individual buildings and blocks and functions at the individual building scale. And then be able to kind of visualize these urban visions by collaborating with visualization artists, and to be able then to communicate with different stakeholders and the clients to keep refining these until we arrive at our final design. So thank you. That's kind of what I wanted to share. If you have any questions, feel free to ask, and I hope you enjoyed.
Yeah, thanks a lot. Thanks a lot, Mateo, for this interesting insights. So I'm going to open the floor for everyone who has a question on YouTube or also in our video conference. If nobody directly wants to ask them, I'm going to start, so you have a bit more time to think about it. I would be happy if you could basically kind of walk us through your design or research process at Fawcett a bit, so you can basically understand maybe a bit more on how far you also determine your the parameters on what for your design in the future. What kind of data set you look in, or how you make decisions in the process, and why you focus on specific aspects in your research. Is that something you could talk a bit about more?
Yeah, of course. Like I mentioned, in our team, it's very interdisciplinary. So usually when a project comes in, big scale master plan, the first thing is to kind of try to understand what the client wants, and then also what we would like to achieve in terms like of an overall urban vision. And here is usually just informal discussions with all the different members involved in the different perspectives that we would have in a project. So with the anthropologists to try to understand, what's the culture like in this in these places that we're working in. Kind of what are the lifestyles that people are leading, and what they would need in terms of like amenities and building types and types of residential or commercial environments. Discussions with the urban planners to understand how these different urban visions might tie into the wider economic context of the city or region or country and where we're working in. And that kind of lets us develop a first design approach to what we want to accomplish. And from there, we can start, we usually start defining then different metrics that we want to be able to quantify or be able to compare against once we start iterating through different design options. So in some cases, for example, it might be questions surrounding what is the pedestrian experience going to be, what is the right streetscape, what is the right street to building ratios that we want to have, all the way to understanding the urban transportation and how different areas are going to be connected up together through public transport or cycle networks. And this kind of then defines the type of methods we will be using and the type of data we will be trying to gather to answer these questions. And then from there is a back and forth between, again, between the designers, the architects, the planners, looking at this data, redefining urban vision and testing out different design options or ideas that we might have, and seeing how it compares to the existing context for one, to how it compares to how other cities function, and to places that we know work well, and again, to what the client actually wants to achieve for that project. So that's kind of how we work and how we incorporate these type of analysis within the whole workflow from the start of the project all the way to the end.
Mm-hmm. And where would you say you would position the architect or the like architects with his competences in that process? Is that maybe rather in the end, or like in the middle, in between, or how did that maybe also your position as a, let's call it, data scientist maybe changes your competence in that discussion?
Yeah, well, it's, I guess the involvement would be throughout the whole process, and it's just a continuous conversation, which everyone kind of brings in their own expertise. So, for example, as we're going through the different analysis or creating the different methods that we're going to use to try to quantify different things, there's always an ongoing discussion with the architects to make sure that we are aligned on the visions of what we're actually measuring or what's actually important for specific projects. So I guess in that sense, the role of the architect, aside from the actual design, is also in the setting up the overall goals or strategies that we might want to take in different projects. And then again, conversing with the different professionals from other fields to just enhance with these different perspectives, whether it be more on the anthropological side, to see if specific design ideas will fit into the cultural context, all the way to working with me as a data scientist, looking at the actual quantifiable data, or urban economists and urban planners to see if how those ideas also kind of insert themselves within the wider economic context and so forth.
Thank you. We have a question from YouTube from Victor from Hanover. He is thanks you for a very inspiring presentation and would like to know if you, using different algorithm and machine learning models, if you ever found unexpected solutions and diagrams.
Oh, that's a very good question. Thanks. Thanks, Victor. I think with machine learning models, not so much. I mean, usually when we find unexpected solutions, it's usually not solutions, but some some error in the model. So actually, our use of machine learning is usually to speed up other processes. But with other algorithmic approaches and just modeling in general, there have been times where we have found unexpected solutions. For example, when studying the network connectivity of an area, sometimes we have realized that a specific part in the master plan that looked well connected on plan, when we actually ran these algorithms and measured their connectivity, turned out to be quite segregated, and then that has led to redefining again design decisions and trying to figure out how to connect those up better, so the whole functions together.
Yeah, maybe to add on that, I'm also a bit curious in how far maybe working with machine learning or algorithm is maybe not just a new digital way at looking at, let's say, issues of urban planning that could also be looked at in a more traditional way, maybe, or in how far using these technologies or looking at other new kind of data sets that you maybe also just use to take from Google Street View, maybe also changes your perception or the way you design it completely, or does it offer you a new layer of perception or a new layer of how you basically perceive or design cities in a way, or is it only only an instrument for you, and that is maybe makes processes more easily understandable or visible?
I think right now mostly it is just speeding up certain processes or making certain things more visible in terms of providing additional insights. But I do see a trend where slowly it is changing also the way we approach and see design. One great example of this, and I would recommend for anybody interested, it'd be worth checking out. It's a paper that was published last year called Beyond Typologies, Beyond Optimization, from some researchers at the ETH. And one of the interesting things about this paper is exactly this, that it highlights how these new methods and new data sets can actually influence or change the way we approach design. And the main crux of that paper was, traditionally we would think about when designing buildings or urban environments, we have this very ingrained idea of a typology. So a tower block typology, a courtyard typology, and so forth. And we're very constrained kind of by this way of thinking. And with new machine learning approaches that are able to kind of generate geometries on their own, they're unbounded by this kind of classification. And when applying these, then the question is, how do you actually navigate or make sense of this design space or the design possibilities that is created by these algorithms? And that does change one, how we use technology and how we approach design. So one of the things they proposed in that paper was on using a type of recommender system to make sense of all these design options that now we have available. So as you would, same as in Netflix or Amazon, where you click on a product and then it tells you, if you're interested in this, here's a host of other products that you might also like. And same thing with, if you see a series, then it might suggest new series that you might like. A similar approach is the computer generates a whole series of possible design options. And you as a designer then kind of select which ones you think might work, which actually makes sense. And then the computer learns from this interaction and suggests new designs that are similar. And I think in that sense, it does change the way we approach different design projects.
So it basically just simply increases your options, the possibilities that you might have for a future design in a way. I mean, it's in a way interesting that it actually also increases complexity in a way. It's supposed to deal with complexity, but it also increases complexity by giving you more options to decide on what might be the best future scenario for a potential client or potential site in a way, right? It's interesting that it's actually not only like helping out reducing complexity, but actually at some point actually also making it more complex, because also not everyone who is at another, maybe let's say as educated as not actually able to read code or read data and then actually find the right solution within that new complexity.
Yeah, I think that's actually one of the main challenges right now, and why a lot of these technologies that have been adopted widely in other fields are still being worked on and developed, and they haven't kind of come into fruition yet within architecture and design, is because they do create this whole new level of complexity, and then the challenge becomes of how actually to tackle that complexity and reduce it back again into something that is manageable. But you see that there's a lot of push and a lot of great work coming out from different places, and I think in a couple of years we might actually have tools embedded within the software we use every day that does this automatically. So you see Autodesk, for example, has this AI division, and it's constantly working on pushing what's possible in terms of actually taking the new complexity that has been generated by these new algorithms and then reducing it back again to something that's manageable and that someone can interact and use on their everyday work.
And maybe for our students, for architecture students in general, what would you recommend and what would you have to learn in a way to actually deal with these new complexities? What would be the programs or software you would actually have to learn to be able to deal with these data sets, or a different way of looking at architecture from your point of view?
Yeah, I think just in general, there's this concept of now data literacy. So just becoming familiar with what data actually is and how they're stored and how we can extract information from them. In terms of actual software, I think learning Python just opens up a whole world of possibilities, because there's just constantly new things being developed within that language that just makes all these new algorithms, new methods a lot more accessible. And then just familiarizing yourself with just more general concepts around what machine learning is, what different models exist, and how they're being also applied to other fields, to be able to kind of think about how you can extrapolate that and bring it into the design world.
Okay, thank you very much, Mateo. I'm currently out of questions. If there's anyone in the room here or on YouTube who wants to ask maybe a last question, now's the time. So then maybe then I'll have a last question, and maybe when trying to looking at that maybe potential or an expert in that field that you're working in on, let's say, let's call it applied data science, where would you basically where would you look at? Where are your let's say idols or people that you use as references for your work? Is it maybe only at Harvard? Is it at Turing? Is it maybe at MIT? Is it maybe I just saw that also at Barcelona? They are actually also inventing a new master's program on what is it called? I think architecture and digital infrastructure, something like this. So where do you look at when you look for references and finding new insight on that work? Maybe also maybe you can mention the work you do with the data aided design group.
Yes. This is actually a great question, because I think finding sometimes references in this field it's complex, just because it's fairly new. So you have to have your toes dipped kind of in different communities, in a sense. So a lot of it comes from work being done within the data science, machine learning world, and usually there's just staying updated with the big conferences, so SNURIPS, ICML, and so forth. Just more general data science, machine learning, because they're constantly pushing the boundary, I think, of especially now, of how you can use 3D geometry data. I mean, we saw kind of in the last 3 years a lot of advancement in working with like 2D images, and you see now, like with the deep fakes or these generative algorithms that can create images kind of on the fly. You're starting to see that now seep into the 3D geometry world, and I think that will open up a whole set of opportunities for architecture and other design disciplines. And then, of course, then specific places such as MIT, they have an urban science group. I mean, also Carlo Ratti and his group that have been doing a whole series of really interesting work. There's a lot of people also at the Graduate School of Design and at Harvard that have been kind of coming into the field and showing kind of possibilities within the design world as well. But like I mentioned, I think it's really about having being immersed in kind of different communities and trying to see what insight from one community, one development, one community might benefit the design profession.
So it sounds a bit like that. It's so far it's a kind of an Anglo-Saxon discussion on future data literacy in some way.
Yeah. And just to mention, as you were saying, so me and a couple of colleagues have started a digital magazine called Data Aided Design, where we're actually trying to tap into what's happening in this field and connect with different professionals and have interviews and just try to get an overall idea of where the field is going and how data is impacting the way we design it in the very general sense. I mean, we've interviewed people who are in the fashion industry, all the way to like robotics and using this for digital fabrication and so forth.
Great. So maybe that's the good question to the end. Maybe you can all have a look at dataaideddesign.com for more information. I would thank you very much for your talk and for your time, Mateo. We will stay online for a few minutes, I guess, but I'm gonna close the on live stream for now, and we'll say goodbye to the online community at YouTube.